Listen up, y'all, cause this is it. The numbers we're making are so vicious. Mathematicious, expeditious can be kinda scary. I hope my answers aren't radical or imaginary. I convert percents to fractions. This brings me some satisfaction, like scientific notation and order of operations. Mathematicious, repetitious, gets me expeditious. My answers make it vicious. My erasers often stitches. I make wishes. I get the answer right, and I'll be staying up all night just to check what I write. Mathematicious.
All right, welcome back, math students, to Algebra 1 2.6. We're looking at solving absolute value inequalities in this lesson. So we will solve these absolute value inequalities, and we're going to also look at something of a little bit of a real life situation as well involving these absolute value inequalities. So this just is our continuing our lessons in inequalities. This will actually be our final lesson here in inequalities before we move on to chapter 3. All right, let's go ahead and look at our cartoon for the day. There's a guy looks like a baseball player. So the outfielder's going back way too far back, and he falls off the cliff. All right, let's get into our inequalities here with absolute values. So here's for a vocabulary word. It's basically what absolute value inequality is. Now we've looked at absolute value equations, which are going to be very similar to the inequalities. Have a little bit different probabilities because of just the nature of the graphs. So we'll have graphs with these. We're not just going to get solutions, we're also going to be able to graph our solutions on a number line. So this is an absolute value inequality. It's an inequality that contains an absolute value expression. So just like the equations were, they were an equation that contained an absolute value expression. And remember, those absolute value expressions are ones with these lines on each side. Those are absolute value symbols. So here's an example. The absolute value of x is less than 2, or absolute value of x is greater than 2. So those are absolute value inequalities. And we can recall that with just absolute value, what does that mean? It means that it's the distance between that number and 0. So whatever's inside of here, that's the distance between that number and 0. So just for instance, if I was to take the absolute value of something, like let's just say the absolute value of 2. So what is the absolute value of 2? So basically what's that saying is, it's saying this: if we had a number line, and we have 0 here, let's say there's 1 and there's 2, so what we're saying is the absolute value of 2 is how far away are you from 2 right here? Well, you're 2 away. The distance is 2. So the absolute value of 2 is equal to 2. But then if I also said, what is the absolute value of negative 2? And so if we go over here to this side, negative 1 and negative 2, and we start again from this point here, and we're going to go this way from 0. The distance from 0 to negative 2 is the same distance as from 0 to positive 2. It is still 2. Distance is always going to be positive. It's not going to be a negative number. So that means absolute value is always going to be a positive number. It can never be a negative number here for absolute value, just because the distance can never be negative. So just recall that, if you were to travel a particular distance, it doesn't matter which direction you travel, you're always whatever you travel is always a positive distance. So if I travel 2 miles to the right, it's going to be the same as if I travel 2 miles to the left. I'm not traveling a negative distance. Distance will always be positive. And so then we look at the graphs of these inequalities. We can see how this one, when it says the absolute value of x is less than 2, it's going to be our connected one together like this. We've seen these before with compound inequalities just in the last lesson. And the one that says absolute value of x greater than 2, well, that's going to be the one that's going to be going the opposite directions. They're shaded in opposite directions. They are not connected. They are what we call maybe disconnected here. So you have your intersection here, as we saw before, and then this is your disjointed one here. So what we can see is you can solve these types of inequalities by solving a compound inequality. So that's what we're looking at. Okay, there's this concept summary in the book, and this is something you might just want to recall and remember. You can remember just from this whole chapter what we've done, one step and multi-step inequalities. It says follow the steps for solving equations. when you're doing those. Reverse the inequality symbol, though, when multiplying or dividing by a negative number. So remember, these are just like solving equations, except when you multiply or divide by negative, you're going to reverse the inequality sign. If we're doing compound inequalities like we did in the last lesson, it says, if necessary, write the inequality as two separate inequalities, then solve each inequality separately, include an and or in the solution. So if it was going to be an intersection, we were going to include the and. If it was going to be disjointed, going opposite directions with a shading, we were going to do an or. And now the absolute value inequality, it says if necessary, isolate the absolute value expression on one side of the inequality. So that's always going to be what we have to do first with these that we're solving. We're going to need to get the absolute value expression by itself on one side of the inequality, then write the absolute value inequality as a compound inequality. So we go back and write it as one of these. Then solve the compound inequality. So now also in your notes you have this core concept, solving absolute value inequalities. So here it shows you now what we would do if we have an absolute value inequality. If it is a less than sign like this, you have the absolute value by itself. So these are our absolute value expression. It's by itself. It's less than a positive number here. C would have to be a positive number. C is greater than 0. We're going to write it as two separate inequalities. So we can write one inequality exactly the same way. You can see this one is exactly the same way as this one is, just no absolute value signs. But this one is going to be a little bit different. We're going to change the C to a negative C. And since we're changing it to a negative, we're also going to switch the direction of the inequality sign. So we're going to always use what's inside our absolute value symbol right here, both on both of these. So that is always exactly the same. AX plus B, that's going to be the same as we start both of these. And then it's always going to be still the same number, but it's going to change the opposite sign on one of them, and then you have to change the direction also on that same one that you're making negative. Now it'll pretty much do the same thing here, except this time you're going to use an or instead of an and, because this is going to be a less than symbol, so you're going to use the word and. This is going to be a greater than symbol, so you're going to use the word or for these guys. So one way to kind of remember that, and this is what I've shown students in the past, is for the less than symbols, this is a less than, you can kind of think of it as less and. Like less and sounds a little bit like less than. And so that would be, we could see it's going to be a C. So if we look at this inequality sign like this, it's the direction of as you would write a C, and C would stand for connected. It's going to be a connected one where the graph eventually will be all connected. It'll be a compound one with an intersection. If it's this greater than sign, we can do the same kind of thing. So the greater than sign, when it's facing this way, we can think of that as great or. So great or sounds a little bit like greater. So great or, and that's going to be kind of going this direction, and so it's, if you line that up, put a little line right here, you can get a D. So it's like how you'd maybe write a capital D and then put a line, and that would be your disconnected one right there. So disconnected for great or. So think of just how would you do this? Well, this is a C for connected, this is a D if you put a line there for disconnected. Okay, so let's get into our extra practice and do some of these solving absolute value inequalities. I'm going to skip around a little bit on this extra practice because I'm going to do all the less than symbols first, all the ones that are going to be connected first, and then I'll do all the sets that are going to be disconnected. So for number 1 here, it already has the absolute value by itself, and so we can see its absolute value is less than a positive number 8. So that's there right there. It's going to be a C for connected, less than is less and. So we can write this as two inequalities. If I wrote out the first one, I can write the first one just kind of the way it shows you here. Just y plus 2 is less than 8. So there's one of our inequalities, and I could say and then the other one could be, again, y plus 2. I'm going to use that twice, exactly the same. And then this time it's going to become a negative 8, so I got to switch the direction of the inequality sign and make that a negative 8. Okay, so I can then solve both of these inequalities separately. Now another thing that I can do is I can put these together in one long statement. So I'm going to do that as well. So if I started with our one here that we start with y plus 2 is less than 8, and then the negative 8 is going to go over here on this side in front, because obviously negative 8 is less than 8, so you want it going in that order. And then you're going to put the same symbol less than there, because that's going to have to turn around. It's going to have to flip this inequality sign around because you're putting it now in front. You're basically flipping this whole inequality around here to give you this inequality. And so now that kind of makes it a little bit easier to solve because you don't have to solve two separate ones now. You can kind of just solve one long one. And so what we would do here is we'd start by subtracting 2. We need to get the y by itself in the middle. And this is what we did in the last lesson. We subtract 2 from both of the negative 8 and the positive 8. And so what that's going to give us here is negative 10. And now our less than symbol with the y, and then less than symbol again, and 8 minus 2 is 6. So there's our solution. This would be our solution here. So I'll circle that. And then for our graph, we'll go ahead and draw a graph down here. Maybe put 0 in the middle. I'll go by 2's, 2, 4, and then there's 6, negative 2, negative 4, negative 6, negative 8, and then there's negative 10. And it's going to be a closed, or not closed, open hole, as we can see. There's no equal to. So if the equal to there is, if there is an equal to, it doesn't change anything about how you solve it. It's just going to change that it's a closed hole instead of an open hole. So we're going to have open holes here on both of these. So this is going to be an open hole at negative 10, open hole at 6. And the shading should be in between. Y is in between those two. So our shading there is just going to be in between those 2 points. All right, number 3. So we're going to skip 2, come back to 2 in just a little bit, because 3 is another connected one. However, 3 does not have the absolute value by itself. So what we want to do is we want to get the absolute value by itself. So I need to undo these things on the outside. So I have a 3 multiplying in front and a 10 adding in the back. You always want to get rid of the adding or subtracting first. So we're going to start by subtracting 10 here from both sides of this inequality, canceling those. So now we have 3, and then our absolute value of 2a plus 5. And then it's going to be less than or equal to 37 minus 10 is 27. And now this 3 right here, it's in front. What we can't do, and make sure you understand this and hear this very clearly, you cannot distribute 3 into an absolute value expression. Absolute value symbols are not like parentheses. If these were parentheses, then we could use the distributive property. But since they're absolute value, they're straight, okay, vertical lines here on each side, you cannot distribute that. This is like walls that you cannot penetrate into. So we have to get rid of this 3 a different way. We're going to divide by 3, just do the opposite operation. So I can cancel out the 3's that way by dividing both sides by 3. And so that's now going to give us the absolute value of 2a plus the 5 is less than or equal to 27 divided by 3 is 9. Okay, so now we're going to see that we have the absolute value by itself. It is less than a positive number. So since it's less than a positive number, then we're going to just go ahead and see that it's connected, because it's a C here. It's like a C. So it's going to be our connected one just like we had up here. And since this is a positive number, we can get actually a solution. Now, there's going to come a time, what happens if it's a negative number? What happens if this was a negative 9? Well, then we get into the special solutions. So we're going to have some special solutions where we're going to get a no solution answer or like an infinitely many answer. So when we see it, have a negative here, then that's one of those special solutions. So we'll talk about that when we come across those. So I'm going to come up here and rewrite this now as 2 inequalities. So starting with the first one, I'll just go ahead and start with the 2a plus 5. I'm just going to rewrite this one the way it is less than or equal to a 9. And then what I can do is I can go straight to this. I don't need to write and then another one. I can go straight to this by just putting the same inequality sign in front of 2a and then putting negative 9 in front of that. So there's my compound inequality now I need to solve. I need to get a by itself. So the first thing I'm going to do is subtract the 5 from the middle and then each end here. So I'm going to subtract 5 from both 9 and this negative 9. And so what that's going to give me here is negative 9, negative 5 is negative 14, less than or equal to, and we have 2a now in the middle, less than or equal to, 9 minus 5 is 4. And now I'm going to just divide by 2, so I need to divide negative 14 by 2 and positive 4 by 2. So now I'm going to rewrite this part up here for my solution. Negative 14 divided by 2 is a negative 7. My inequality sign is less than or equal to. Now I would change the direction if I was to divide by a negative. Don't forget about that. That's always going to be the case anytime you deal with any inequalities. So 2's cancel now, they're in the middle, so now we just have a, less than or equal to again, and 4 divided by 2 is 2. So that's our solution, our compound solution. And we need to put these numbers on here. So I'm going to go ahead and put 0 here in the middle, and I'll go by, let's see, I'll go by 2's again. So there's 2 and 4, here's negative 2, negative 4, negative 6, negative 8. So that puts negative 7 kind of right in the middle here. So there's negative 7. So I'm going to put down closed holes on this one. As you can see, it's got the little equal to. So it's going to have a closed hole at the negative 7, closed hole at 2, and since we got it as a compound inequality because it was connected with a C, we know it's connected with that less than symbol, and we can shade in between. Alright, move on to another one down below. Okay, so number 4, we're going to see that one. You can see its absolute value is already by itself, and it is going to be less than or equal to 4, so the less than part's the important part to see, and it is going to be a C for connected, so it's going to be a less than or a less and, so it means we want to either use the and symbol with two inequalities or put it all together. I'm just going to go straight to putting it all together again, because I think that's what you're going to see most often. So we're going to start with just writing out what this inequality is here. So let's go ahead and write out the y minus 3, and it's less than or equal to the 4. So we write out what the inequality is without those absolute value symbols, and then we're going to write the front part of this, which is going to have the same inequality symbol, less than, and then just the opposite of 4, which is negative 4. So that now goes in front there. Remember, it's always the same number and then the opposite of that number. Now, so long as it's positive here. It's only what you're only going to be able to do this when it's positive. So now we're going to go ahead and just get rid of our 3 here by adding 3. So when we get rid of that, we can cancel the 3's out, and then add 3 to both of these ends, to negative 4 and to positive 4. So we do that. We're going to see over here on the left, negative 4 plus 3. Take 3 away from negative 4, it's going to give you negative 1. And then the less than symbol, y is now in the middle, and then your less than symbol again. And then 4 plus 3 will give you 7 for the other number. So that is now the solution of this absolute value inequality. We just need to get the graph of it. And so then we're going to put down a number line here. We need to include negative 1 and 7 in this number line. So I'm just going to go by 1s. So start negative 1 here, and then go by 1s all the way to 7. And it's going to be closed holes at the negative 1 and at the 7. So closed hole at negative 1, closed hole at 7. And it should be shaded in between because they're connected. You can see it's the C up here for connected. The Y is in the middle in between. So it's all connected. Alright, so number 6. First thing we're going to do on number 6 is we have to get the absolute value symbols by themselves. I need to add 4 to both sides. So I'm going to add 4. And once I add 4, I'll have my absolute value of the 3 plus r. And then my inequality sign is still less than. And then 0 and 4 make 4. Alright, so at this point I want you to pause the video and I want you to write out the two inequalities, or write out this compound inequality, solve it, and then once you get the solution, graph your solution on the number line. So pause the video and do that now, and then go ahead and push play again to see if you're correct. Okay, so you should have paused the video. Here's what you should have now. So if we take out we have the 3 plus r, take that out of the inequality symbols, we'll use that, then our inequality sign in 4, less than 4, so that's going to be our first part of it. In front of this 3 plus r part, we're going to put another less than symbol in front, and then the opposite of 4, which is negative 4. And so now we just got to get rid of 3, so we're going to subtract the 3, subtract the 3 from 4, subtract the 3 from negative 4, and so now we start to say, okay, negative 4, negative 3 is negative 7, our inequality sign less than, we have r then in the middle, inequality sign again, and then 4 minus 3 is going to be positive 1 over here. So now we have a negative 7 and a positive 1. So that is the solution you should have gotten, all connected together. And then let's go ahead and graph it. We're going to want to put a number line down. We got -7 here all the way to 1. I'm going by ones. So -6, -5, 4, and so on. And we're going to put an open hole on this one because there are no equal to lines. So open hole at -7, open hole at 1, and your shading should be in between. So that's what your answer should look like for 5. Okay, so we're skipping number 6. We're going to come back to 6. All right, let's take a look at number 7. Number 7, again, has the absolute value by itself. It is less than the number. But this time, look at the number. The number is negative. So this is one of those special ones. When the number is positive, you're always going to get a solution that you can solve and get some solution set and some range of solutions, whether it's connected or disconnected. That's if it's positive, if it's either less than or even greater than a positive number. But if it's going to be less than or even greater than a negative number, then you're getting a special solution here. So let's take a look at this. How would we think about this? Is it going to be no solution or infinite solutions? So just remember the fact, recall that the absolute value is always got to be positive. So this right here on the left side has to be positive because that's just the definition of absolute value. Absolute value is always positive because it's always talking about a distance from 0. And if we say, okay, if this is positive and that's supposed to be a less than symbol and this is a negative number, think about that. Is that a true statement? Positives are less than negatives. And you know that's not true. It's never true. So because that's not true, then there's no solution to this. There's no way to get a solution because positives are never negative, never less than a negative. So there's nothing to put on the number line. We got to leave it blank. There are no solutions to this one because it's less than a negative. So if your absolute value when it's by itself is less than a negative number, it's going to be no solution because positives can never be less than a negative. All right, let's move on now. We're going to look at our joke of the day. So how do baseball or softball players keep in touch? How do baseball, softball players keep in touch? You're thinking maybe Facebook, cell phones. How do they keep in touch? Well, they touch base every once in a while. Touch base. That's a baseball joke because of all the bases are on the diamonds. All right, we're going to go on to disconnected now. Disconnected inequalities. All right, so we're going to go back to number 2 because number 2, you can see the absolute value symbols are by themselves, but this time it says greater than +2. So if it's a greater than, it's going to be a disconnected one, like the shape of a capital D there. So this is not going to be a connected inequality statement. We're going to have to disconnect this with the word or. So we're going to write out 2 separate inequalities. We have to have 2 separate inequalities when it's a greater than symbol. The shading should be going the opposite directions on the shading. So when we write out our first inequality, you can start with this one here that you see, where it's greater than 2, or you could start with the adjusted one that you do. So I'll show you that you can just start with the adjusted one just as well. So it doesn't make any difference which one you start with, you just have to have 2 down. So we're going to use the q divided by 3, and if I was to say, okay, this is +2, I'm going to put a -2 on this one, which means I got to change the direction of our sign. We're going to flip the sign around, so now it's less than a -2. Now we'll put the word or, and then the other one will be exactly what this one is, just the q over 3 greater than +2. So it doesn't matter which one of these you put on which side here. So I could have put this one first and then this one second. It doesn't make any difference. I just need to solve each one separately. So I can see I'm going to have to get rid of the 3 here. This is q divided by 3. So it means I need to multiply both sides of this inequality by 3. So start with multiplying this by 3 here. That will cancel the 3's out, leaving q by itself. Multiply -2 by a 3, and so we'll get q by itself. Since I'm multiplying by a positive number, I don't change the direction of that sign. It stays the same. It's less than. -2 times a 3 is going to give me -6. Okay, so I'm going to put the word or next to that. Now I'm going to come over here and solve this one the same way. Multiply both sides by 3. So multiplying this by 3, the 3's would cancel again. And then multiplying over here by 3, I'm going to get a +6 this time. So q is greater than 6. So this right here, both of these inequalities with the or in between them, Make sure you always put the or in between. That's my solution statement. So that's our solution statement. Now we just got to graph that statement. So we need -6 and +6 on our graph. I'm going to go by, put 0 kind of in the middle, and then just go by 3s. I could have gone by 2s. I just decided to go by 3s this time. And so that puts me at closed, or these aren't closed, these are open holes. So they're open holes, there's no equal to. So we have an open hole at -6, open hole at +6. And this one's not shaded in between because they're going opposite directions. This one says Q is less than -6 and Q is greater than +6. So this one's going to be greater than +6. This one's going to be less than -6. Opposite directions when it is disconnected with a greater than symbol. Here's another one. It's got the absolute value by itself. It's greater than, but look at this. This is not a +4. That's a -4. So that's where you're going to have that's a red flag. Whenever this is negative over here on absolute value, even equations or inequalities, that's always a red flag. Wait a minute, I'm going to have a special solution here. It's either going to be no solution or infinite solutions. So on this one, we're seeing that the absolute value here, remember, which is always positive. Remember I said this is always positive. So you're going to have a positive, then your greater than symbol, and then a negative number. So what about this statement this time? Positive is greater, positives are greater than negatives? That's always true. Positives are always greater than negatives. So because it's this way, with a true statement that's always true, we're going to say either infinite solutions, or we could say this, all real numbers. All real numbers mean everything that's on this number line. It's infinite solutions, same thing, you can say that, but most of the time you'll probably see this, all real numbers. You can even abbreviate this ARN even. But as on the number line, what are you doing in the number line? To graph this one we just shade the entire number line. The whole thing shaded. Because it's every number there, both directions from -infinity to +infinity. Alright, so look at number 8. So number 8 has the absolute value symbol, then it says +8 greater than or equal to 17. So it's not by itself yet. So before we really can, identify if it's going to be a connected or a disconnected one or whatever it's going to be, we have to make sure, even before we can decide if it's going to be a special solution or not, we have to always get the absolute value symbols by themselves. So this expression has to be by itself on this side. So we need to undo the 8, so we got to subtract 8 from both sides. It's going to cancel our 8's here, so it leaves me just with my absolute value expression now, 4x minus 7 and those absolute value symbols. The inequality is still facing the same way, and we don't change it when we subtract 8, only when we divide by a negative or multiply by a negative, not when we subtract by a number. So our inequality sign stays the same, and then 17 minus 8, it's going to give us 9. So now we can see, okay, absolute value is greater than a positive. We're going to get a solution because it's positive, and since it's greater than, it's going to be disconnected here. So we know the shading should be going opposite directions. We got to write two separate inequalities. If I start with the first one using 4x minus 7, I'll do that. I'll use this the same on both. 4x minus 7. I can switch the direction of this inequality and then make this its opposite number. So make it -9. Then I'll put the word or, and then I'll use the same inequality again, 4x minus 7, and then I'll keep this all the same, greater than or equal to a +9. So this one I'll do the same. Now again, like I said, you could put that one first and then do this other one with a -9 second. Now just solve each one individually. So we're going to first, on this one, add 7 to both sides. And so that's going to give us, now cancel 7 to 4x, and then our inequality sign is less than or equal to -9 plus 7 is a -2. And we just divide by 4 now, because we have to undo 4 in front of x. So we divide, because this is 4 times x, opposite of that would be to divide. So 4's cancel out, leaving x by itself. So we're going to get the x by itself. The inequality symbol is still facing the same way, divided by a positive there. So it's still facing the same way. And then I have a -2/4. I just want to simplify that to a -1/2. 2/4 reduces to a 1/2. Just top and bottom by 2. Now if I come over here and do the same thing, add 7 to both sides again here. I'll put the word or. Don't forget about the word or. We need to keep that in our answer. So I add 7's again here, cancels those, and then we have 4x again is greater than or equal to 9 plus 7, which is 16, and then I divide by 4 again. So when I divide by 4 this time, we're going to get x by itself, greater than or equal to, and then 16 divided by 4 is 4. So that could be our solution right there. That'll be our solution for this one, our solution set, we would call it, our range of solutions. And then we're going to just put this on the graph. So let's go ahead and try this now on the graph. We'll go and put some numbers down. I need it to have 4, and I need to have it include negative 1/2. So if I go by ones here, starting 4 here, 3, 2, 1, 0, negative 1, the negative 1/2 is going to be right here between negative 1 and 0. So negative 1/2 is going to be right there. I'm going to put closed holes on this one. They're both going to always be the same because we're using the same inequality sign here. So they're either both going to be open or both closed. We're not going to ever see one of each on the absolute value ones. So since they're both closed, I'll put a closed hole at the 1/2, and I'll put a closed hole at 4. And here we're going to shade. This is going to be x is less than the 1/2, but greater than the 4. So it's less than 1/2 going in the negative direction, greater than 4 going in the positive direction there. That's away from each other, so they're disconnected. All right, so for number 9, I'm going to have you try this one for number 9. So start to finish, go ahead and give your best shot at doing number 9. First, get the absolute value symbols by themselves. You got to get rid of 14 first. Then you have to divide out by 6. Remember, you cannot penetrate that in. You cannot use the distributive property with 6 there. So get the absolute value sum at itself, then you can write your two inequalities and then solve it and then graph it. So go ahead and pause the video and do that, and then play it when you're done to check your work. Okay, hopefully you paused the video, or you paused the video and now you're finished number 9. Check the work on number 9 here. First, we're subtracting 14 here from both sides of this inequality. That leaves me with the 6 in front of my absolute value symbol, 3 minus k. And our absolute value, or inequality symbol is a greater than still, and then 14 minus 14 cancels there as well. We're going to get a 0. So now I just need to divide out by 6. So divide by 6 there, cancels the 6's over here. So it's going to give me my absolute value sign by itself, the absolute value of 3 minus k. My inequality sign is still facing the same way, it's still greater than, and 0 divided by 6 is 0. So since it's greater than 0, it's not greater than a negative, so we're not getting a special one here. It's greater than 0. So it's kind of like we might get one solution out of this, but we have to still write out two inequalities because one of these is going to be going the other direction. So our first inequality, we'll use 3 minus k, and we can change the direction of the inequality and then write 0. There is no opposite of 0, it's still 0. And then we'll put the or, and then 3 minus k again, and this time I'll use the same one here, greater than, and then 0 again. So I just have to have both of these out. One's going to be less than 0, the other one's going to be greater than 0. Solve each one separately. So we're going to have to subtract 3 from both sides first, and that's going to end up giving us a negative k, because now I have negative k on this side, less than 0. Or sorry, not 0, 0 minus 3, which is less than negative 3. I can't leave k negative, so I need to change that by multiplying it by negative 1. Basically, if we do that to both sides, it's just going to change everything. It's going to change the sign to be positive here, the sign to be positive here. It's also going to change my inequality sign to face the other direction. So it's going to be k greater than 3. And then I'll put the word or. Do the same thing on this one. Subtract 3 first. And so I'll have a negative k is greater than negative 3. And I'll do the same thing. I'll change all of the signs because I'll be basically multiplying the entire thing, everything there by negative. So now positive k is greater than positive 3. So I'm just going to kind of clean up this answer a little bit better. So I'm going to put it like this over here. K is less than 3, or k is greater than 3. It's got the same number there, so as we graph this on the number line, so this is actually our solution set right there. That's our solution. But as we graph this on the number line, we're going to see that we're going to only need to put 3 on the graph. So there's 0, 1, 2, 3. I'm just going to have only a hole at 3. It's going to be an open hole. So it does not include 3. So it's an open hole at 3, but this one, this inequality says k is less than 3. And this one says k is greater than 3. So we have a shading going off to the left of that hole and a shading go off to the right of that hole. So basically this is close, very close to being all real numbers. It's just basically it is all real numbers except 3. So you could even say that as an answer almost, all real numbers except 3. But that's what it would be. This is the inequality because it's everything here except for the number 3. All right, we have just one more. We're going to look at a real-life situation problem, and then we'll be done with our lesson. All right, so the solving real-life problem is going to be having to do with absolute deviation. So deviation is a word that we also learn in statistics, and we might do that eventually at the end of this book. There's a chapter on data analysis and statistics. So we'll get into that word a little bit more there, I suppose, and we're even going to get into the word mean as well. That's another word that we would need to use for this. Mean, you should know that from a previous math class. Mean is just the average. So if you were to find the mean of some numbers, of a data set of numbers, you'd add all those numbers up and divide by the number of numbers. But absolute deviation is basically how far does something go from one side to the other side of a number. That's kind of what absolute value is. Remember, absolute value is the distance from 0. So at the very beginning, when I was showing you that example from absolute value of 2 and absolute value of negative 2, that's a deviation from 0. So the absolute value deviation from 0 is going to be, or from, I guess, from a 2 or negative 2, it's going to be, the distance there is 2. So you can have from 0, it could be negative 2, or it could be positive 2. So that would be kind of your inequality. So as we kind of look at this one, I'll go through this one with you really quickly. This one you do not need to copy down. It is in the textbook. But I'll just go over this. Here's the data set of numbers. You're looking at some computer prices. You want to basically buy a new computer. The table shows the prices of computers in a store. Advertisement. You are willing to pay the mean price with an absolute deviation of at least $100. So remember, the mean price is the average price, and the absolute deviation means basically this: give or take $100. So if your average price was, let's say, $300, then you could say I'm going to pay. I could pay between $200 and $400, give or take 100. That's what we're doing here. So how many of the computer prices here in this data set then meet that condition? And so we'll just look at the part here that does that. So when we solve the problem, we want to find the mean. Finding the mean adds all of these up, gives us this number 6640. When we add them all up, divide by the number of numbers, which is 10. So that's $664 is the average price of the computer. So what we want to do is use our absolute value deviation. X minus that given number is less than or equal to the 100 that we want it to be, the give or take $100 number. And so now if we just solve this, absolute value inequality like we've been solving them, make it into, like I said, this is why it's a connected one, so we can connect it all together. So that's why you're going to see this most often. That's why I had you solve them this way. So you have this written down, you're going to put that same symbol over here, less than, and then instead of 100, it's negative 100 here. We just need to add this 664 to both sides, and so it's going to give us our answer here of 564 to 764. So your range of what you would want to buy would be between those two. So there's, let's see, 1, 2, 3, 4, 5, 6 computers. It even says there's 6 prices meet this condition, because you're going to consider prices that are at least 564 and at the most 764. So there's 6 of those numbers up here that meet that condition. All right, let's do one on our notes here on your journal, number 10. Okay, so here's number 10. So at a certain company, the average starting salary S for a new worker is $25,000. The actual salary has an absolute deviation of at most $1,800. So remember to think about this. The $1,800 is your give or take number. So the starting salary could be it's $25,000 give or take $1,800. So it could be $1,800 less or $1,800 more, basically. Write and solve an inequality to find the range of the starting salaries. So again, we're going to be using this as our absolute deviation, the absolute value of x minus the given number. Okay, so the given number here is the actual salary number. The average number is going to be your given number here, which is 2,500. And then the inequality sign we're going to have to write is at most 1,800. So remember, at most means it can be, the most it could be would be 1,800. So we're going to say, start off with the x minus 25,000. That's the average number that goes in here. And then less than or equal to, so the most it could be, it can't be any more than 1,800. So that's our absolute value inequality that we now need to solve. So we wrote that. So that's why I circled that one. That's the first part of this. It says to write. So we wrote the absolute value inequality. Now we need to do the second part, which is solve it. So we're going to start by rewriting this x minus 25,000 here, less than or equal to the 1,800. And then we're going to put the same less than or equal to sign on this side over here, because it's a compound inequality that is an intersection. It's all connected together because it's got our c here. And so we're going to put a less than sign in front of that x and then a negative 1,800 in front of that. So we're going to give or take 1,800. So it could be 1,800 less or 1,800 more than this number. So when I just add that number now to both sides, it's going to cancel there in the middle, add it to the 1,800, add it to the negative 1,800, and so we're going to get on this side over here a 23,200 is less than or equal to x, which is less than or equal to, when I add 1,800 to 25,000, it's going to give you 26,800. So what that basically means, and that's the solution to the inequality, but what does it actually mean? So basically, for the salary here, what this means is that starting salary is going to be between, so starting salary, y, is between 23, this is going to be dollars here, dollar sign, things not writing very well, 23,200 and dollar sign 26,800. So that's where the starting salary is going to be, between somewhere in that range of salaries. That's what that means. All right, so that concludes our lesson here on 2.6. That concludes our lessons on even just inequalities, for that matter, in Chapter 2. All right, so I'll see you in Chapter 3.